Welcome to MRS Bulletin Society News, our career journey series. My name is Priscila Cavassin, and we're meeting today with Ramu Banavath, who did his PhD in materials at Indian Institute of Technology, Bombay in Mumbai, India. He's currently a postdoctoral researcher at Texas A&M University in the US. Ramu, thank you for meeting us today.
Yeah, thank you so much for this opportunity and the introduction. So it's an honor to meet and have a conversation with you and try to share means my journey here. So this is Ramu Banavath. So I have done my PhD as you introduced at IIT Bombay, and I have done my PhD in electrochemical biosensors, especially means in the materials perspective. Have been working on graphene and 2D materials there, and then last year I have joined in here at Texas A&M, and here also have been working on biosensors, especially wearables and the point of care device for cardiac arrest and other things. And then I shifted a little bit means 3 months ago to the other lab where means it is under Dr. Micah Green, and it is a different department where I've been working in especially the materials perspective, especially the carbon materials and 2D materials like magazines for different wearable electronic applications. So it's an honor to be here to share my journey. So this is quite exciting to share my
Thank
journey
you.
here. Yeah, yeah.
Thank you so much. So, could you tell us a little bit more about what is your current research topic?
So right now, I've been working with, uh, especially the graphene, especially the a lot of industries have been working with. There are a lot of industrial projects and as well as my personal projects. If coming to the industrial projects, I've been working, converting a waste carbon into useful electrode materials for especially the energy storage and by electrochemical sensors, like let's say an example of pet coke. I've been work means means it's an industrial waste basically. How can we convert into a useful electrode material for especially energy storage, a kind of thing, and it can be as an electrode material for the electrochemical sensors as well. So that is one topic that I've been working on. Another one is the current exciting topics. It's a vaccines. So the vaccine worlds, Dr. Green is working extensively on the vaccine thing. So we have been using different synthesis methods to synthesize, like the common synthesis methods are really harsh. Like people use HF, hydrofluoric acid. We are trying to use molten salt method to means change the means harsh environment to really mild environment, so that we can synthesize in more sustainable way the mixing things, and then we can apply into really different functional applications.
Thank you for your answer. And what would you say was your main motivation to pursue a career in material science?
Started with means my bachelor's. So when I joined in bachelor's, actually it was not intentionally I joined in material science. It was a by means choice, that it was a choice. Means I had to join it possibly because of the college that I've joined. So those are the seats that were available. At the starting, I wasn't interested in material science, but means after getting into it, I got to know like everything is material science. So every field involves material science. Without material science, all other fields are like really empty. So I got to know about the metals, like polymers and other things, how they can, like, let's say materials, the strength and the means different kind of application where they go, and the polymers, the insulating properties and all those things. I got to know more and more about means the materials, what they can do to the real world. Everything is made up of material, means. And then I was really interested, means slowly then the real interest that I got is at the end of the bachelor's, that we need to do a project. So then I have started a project, means with one of the professors in my university, where we need to use metal oxides as a coating material on metals, means especially the paints, where we can inhibit the corrosion of the metals. So then I got to know, okay, we need to synthesize the material, the real crisp of material science that I get to know, like means, okay, the materials can, like means I can do the material science in a really way where I can show the functional application of the material science. Then I used to synthesize the, like means, iron oxide nanoparticles, and where they can be used as a functional like means inhibitors for as a like means corrosion resistant paints. Then I got to know, like, okay, I can do the material science. So, and I got a really good advisors at my bachelor's stage, like means, because as a bachelor student you really don't know, like means, about anything about the research. There should be a proper, like means, mentor need to be there to get to know you, like means, how does the research goes on. And they gave me a little bit of crisp, like means, you can join as a PA, you can choose a PhD career if you're interested in doing all these things, like like going into material science, where you can show your real life applications, where how the material science can really help the functional applications, like example that I have done, the corrosion resistant paints. And then I got a, like means, really crisp idea, like, okay, I can do this, I can go into the really material research field, and really I can change something. And then I got into the PhD. At the starting of PhD, I would really say I really don't, because I've joined from a bachelor's, I didn't do the master's. At the starting it was really confusing how to do the literature, nothing, I don't know actually. And then I got to introduce to the really seniors and really good mentors at IIT Bombay. They help me, they give me really good freedom to do whatever I can do. It was, there are no restrictions. The mentors that I got really really good, they are like really free, like means whatever you can do, you can, like means. And then I got to interact with a lot of seniors in the department, and they, like means, what they work, because at the starting you really don't know, like means, how to start the things. So to start that, at the starting I was struggling, but after interacting with the seniors in my lab, means what they are doing, then like means I got into, like, okay, the material science, especially our lab works on at that time works on the solar electrode material for the, so like means, solar cells, and different other kind of applications like ceramics and other things. And one of my seniors, Dr. Shivasankar Naimala, he used to work on graphene and other things. Like means, at the starting, it was in 2013 or something. At that time, graphene was really, people are working aggressively on the graphene, like means, and different applications. So we used to work in the as a electrode material, especially the counter electrode material for dye-sensitized solar cells. And then, okay, the graphene could be interesting for me, and I can apply into, like means, really apply it to a really functional applications, and where I've chosen as a, like means, especially for the biosensors, electrochemical biosensor, I can apply it. But there are a really limited work it was done, and then I chose, like, the graphene can be a really good candidate, even though that means work has been done a lot of, but I can, at least in the processing kind of point of view, I can do it in the really large scale. So then I have started a liquid phase exfoliation of graphene for in a large quantity for flexible, variable, and biosensors, where I got a really good mentors, Dr. Professor Rohit Srivastava. He is an expert in biosensors, so he gave me really good like means like means, it's a really motivation things, like means, at the starting, because at the starting I really don't know, like means, how to start it. Then he pushed me, like means, to towards it, to how can we really like means applicable in the real life application. Then I started like means large scale synthesis of graphene, and then I tried to apply into the, like means, biosensor. At the starting it was really difficult, and then I got a really good uh, mentors from his lab, and they helped me to, like means, how can we go into really a real life application where I can show the wearable sensors. And then I've done really good work in terms of like analyte detections, like hydrogen peroxide, dopamine, and different kind of analytes that I have done there. So that is how uh, like means, my journey started actually into the biosensors and the material science. Yeah.
Yeah, thank you for sharing a little bit of your career path with us. It's very interesting, and I agree
Yeah,
with you that material science is a really exciting topic. Yeah. And
yeah,
building up on what you mentioned about the mentors, uh, when you're talking to like young career researchers, what would you tell them? Like, how do you find someone to champion your work and your advancement in the field? What would be your
yeah.
advice for them?
Okay, thank you. So, at the starting of my career, whatever the mistakes that I have done, and from that, the things that I have learned from my mistakes, I try to share. So, at the starting, as I said, I was really blank what to do, and like means I don't know anything. So, and I started like with the trial and error kind of thing. So, people should not start it in this way. First, I would say like means I have started in that way. That's why I would say like means I didn't do that much great, but people can do really great if they get to know about their topic. If they are working in certain area, like let's say the biosensors, so first you get to know like who are the champions in your field, like means who are doing really good work, get to know about their work. And I didn't do that. That was really sad. But people need to do this. They need to like means find out who is doing really great, try to interact with them, try to read their literature, like means do they like means try to read their work, how does they are doing. Like at least if you, even if you are limited with the resources, at least the least work that they do, you can start it with that. Then you can correlate the real life, or like means what is the problem right now going on. You can really correlate with that. If you don't do that, you'll be really behind. So that is one thing. And try to interact, like means try to attend the conferences, because if you don't get to know, like means try to attend the conferences. Even if at the time of the I was doing PhD, the COVID was there, you can attend the online conferences if it is not available. Like if it's in-person conferences, you can attend a lot of workshops and then get to know about your topic, and that really motivates you, and as well as get to know you, like means what is going on right now. That is one thing. And when you interact with the seniors, first and foremost, the thing that you need to do is, apart from these things, first you need to interact with your seniors first. Because if they are in the same topic, first you need to, they will tell you like means how can you approach the things, like how can you approach the seniors, professors, and try to talk to them, and try to show like means after a while, means when you face the problems in your, while you do start the research, you might be facing a lot of problems. Try to interact with the your mentors, your seniors, and as well as your like means like guide of your PhD like supervisor. Try to interact with them, and they'll, it will help a lot of things actually in that way. So, and as well as in real life scenario, I would say the industrial things, not only doing research is obviously the science is really exciting. Apart from that, how can this science, the whatever the science that you are doing, you get to know like means your topic, who are the champions, and how they are working. If you have started working, and try to see whether the work that you are doing, whether it is really going to the real life world, whether it can impact or not. And that way you can choose a really good, a smooth path. But yeah, I would suggest in this way, these ways, that a starting career, that you like for a starting a PhD student, I can suggest these things.
Thank you. I think these are great tips. And a final question, what would you say were the main challenges that you faced to get to this point? It could be technical challenges, or also if you would like to share some personal challenges or things that came along the way.
Yeah, I'll try to summarize it. So as if you are coming from a master's and doing PhD, that there you get to know a lot of things, because in the master's you will be doing a really good thesis project, and you get to know about the things that you'll be doing in PhD. Because master's is kind of research, you must be mostly involved in a lot of research thing. But coming from bachelor's to PhD is a really difficult thing, because you need to do a lot of coursework and need to manage a lot of things actually. And to really get into the crisp of the research, it takes time from the bachelor's to the PhD. So that is one thing that I faced. Like means it took me a lot of time actually to get into the relay field. Like actual my research, it was started at third at the third year of my PhD. So for that, you need to interact with a lot of people to get to know like means how the things are going, how can you resolve the things in the PhD. At the starting nothing works, so to make it work you need to work hard, do trial and error. Like if you don't know, like because at the starting of career, if you are coming from bachelor's, you really don't know like what to do. So only thing that you can do is at that time I didn't know. I one thing that as I told you, like means you need to get to know like the who's the champions in your field. But I don't know at that time, so I had to do trial and error a lot of things. And in my lab, the field that I have started, the biosensors, there were no like means I was the only one who was working. The other people who were mainly working on the solar cells and other things. So I was the only one who was working. So I need to start everything from like means everything from the starting, from the scratch. So everything I need to learn from the scratch. So I had to do a lot of trial and error things. I failed many times obviously. So but that more like means because of that I have learned a lot of things, how to start a new lab. Like means as you are starting a new field, what are the things are needed, how can you establish a new lab, all these things you'll get to learn. Even though like means I didn't do at the starting of my PhD really great, but I did learn a lot of things, especially at the real life scenario. Like if you say in the biosensor itself, so what are the things are needed, especially for biosensor lab, like to start, what are the if there are no one, you have to trial and error, do the trial and error and start it, like means whether it will work or not. And many times you will fail. So that is one of the difficult thing that I faced throughout my PhD. And I how I overcome this, as I told you, like means you need to do multiple repetitions and do trial and error and try to figure it out. It does take time, but as I told you, without like means proper expertise and nothing, that you will experience the things, you will do the things by yourself. Uh, that learning is different than the smooth way of learning, like means guiding, getting a guidance from the seniors and the like mentors. This learning is completely different. That you can like means in future, if you wanted to be in academia, you can establish your lab easily because you have experienced all these things. So that will help you in that, in a sense that helped me a lot of things. Because when I came to do my postdoctoral study, that's the lab that I have started, it's completely a new lab, so I had to establish the lab and start my work. So I did that. Whatever the challenge that I have faced in my PhD career, I could help. Like means that helped me to do like means start a new lab and try to establish it in quick way. Like means within 2 months, we could able to establish the lab and start the work in here. So that helped me a lot, I would say.
Thank you, Ramu, for talking to us today. It was very interesting to hear more about your career path.
Thank you so much for the opportunity. It was honored to share means whatever the hurdles and whatever the problems that I have faced throughout my career. Hope it helps some a new PhD student that they can learn something from my journey. It was an honor to share my journey here, and thank you so much for this opportunity.
Thank you. My name is Priscila Cavassin. For more news, go to mrsbulletin.org and find us on X at mrsbulletin. Thank you for watching.